Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, so we see each other again. So before we start our class today, so there are few reminder for all of you. Okay, you can read the etiquette for the online class on the screen, just to make sure that our class will proceed very smoothly. It is very important that you are ready. Make sure all your books and stationery is ready, just in case that you want to take notes. And make sure you are comfortable. The room or the place that you are in now is well lit, and then you can do some light exercise in period in maybe every 20 minutes, also just to make sure that you are comfortable. Okay, please make sure that you also make annotation, just to make sure that the learning is active rather than you just listening to my class or my lecture. And if you do have question, you may ask at the end of the lesson, or what you can do, you can actually consult your chemistry teacher, because this is a recorded lesson, so you might not be able to ask in the question Q&A session after this. All right, I hope everyone is ready, so let's make a start. All right, so today we will be covering about two members of two homologous series, okay, in organic chemistry, which is alkanes and alkenes. Basically, we already covered about the homologous series in our previous class. I hope that you already revised on that before you actually attending or before you are watching this video. It's going to be much easier for you to understand about alkanes and alkenes if you understand about the basic homologous series with the notes provided for you previously. So what we're going to learn at the end, what you are expected to learn in this lesson. So basically, you should be able to describe what does it mean by alkanes and what does it mean by alkenes. Okay, the main reason why I covered both homologous series in the same lesson, so that hopefully at the end of the lesson you can see the difference between these two homologous series. Okay, you should be able to, hopefully you should be able to name and draw the alkane and alkenes. State the trends in physical properties of alkane and alkenes, including boiling point and melting point and boiling point, density, physical states at room temperature, and so on. Okay, how those properties varies in alkane and alkenes. And finally, hopefully you should be able to actually describe about the chemical properties of alkane and alkenes. Okay, so basically this is the main four important points that we will be covering today. We're going to start off with alkane first, and before we proceed to alkenes. Okay, let us refresh back what we learned in a homologous series. Can you recall four important information about alkanes? So basically, what is alkane? The alkane is a hydrocarbon. So hopefully you still remember what does hydrocarbon means. Okay, hydrocarbon basically is a chemical compound that consists of hydrogen and carbon only. There's no other atom other than hydrogen and carbon. This is quite important. The general formula for alkane is CnH2n+2, and then the n, the integer start from 1. Okay, the n can take up the number from 1. So So please bear in mind that because some general formula, the n start from 2 and some start from 0 as well. So you should be careful with that. Alkene also known as saturated hydrocarbon. Okay, we also already covered on this in our homologous series lesson. Okay, saturated hydrocarbon means that there's no multiple bonds in alkene. So there's no double bond, there's no triple bond in alkene. Then basically there's no obvious functional group. All carbons in alkene are bonded with single covalent bond. Okay, so if you see all carbon bonded with single covalent bond and there is no other functional group in that particular compound, then basically this is actually alkene. Okay, so basically this describe briefly 4 important information about alkene. You can read more in your textbook, or you can actually watch from the video the sources for the alkene. In your previous folio, I believe you already covered about fractional distillation, and so you might come across with the cracking as well, which is also one of the way to produce alkene. All right, so let's move to the second part of alkene, which is this is quite interesting part for some student. Some student might find it quite difficult, which is naming the alkene. Okay, how to name the alkene? If you are given any, if you are given a chemical formula or you are given a structural formula, how you going to name the alkene, right? All right, we have one example over here. Okay, if you can see from the screen, there are actually few steps that you can follow before you can actually name the alkene. Okay, step number 1. Okay, if you are given the structural formula for the alkene, or if you are given the chemical formula for alkene, so you need to translate that formula into structural formula. For example, if you are given C5H12, how do we know this is actually alkene or not? So you need to refresh back about the general formula for alkene. Okay, if n equal to 5, H is supposed to be, okay, 2 times 5 is 10 plus 2 is 12. So this actually match with this general formula. So that means that this chemical formula belongs to alkene. So you can actually draw alkene. So remember, each carbon atom can have 4 bonds. Okay, can have 4 bonds. Okay, we already covered this as well in our previous lecture in homologous series. Okay, identify the longest carbon chain, or sometimes we call it carbon backbone. Okay, here can you actually identify how many carbon atom in the molecule? Okay, here is actually the longest one. So we have how many? We have 4 carbon atom. Okay, we have 4 carbon atom. Right, number the carbon atom in the carbon chain. Okay, so it's going to be, maybe it's not the case for this one, but later on you will see that the numbering is quite important when you want to name the when you want to name the alkane or alkene, or in fact most of the homologous series you need to know how to actually number the carbon atom. Okay, so I show you here there's 2 ways of numbering, which you can start from the right or you can start from the left. Okay, at this stage, so you might not see the significance of this practice, but later on when we see more complicated molecule, so you're going to see that this numbering is this practice is quite essential in order for you to get the correct name. Okay. Number 3, name the longest carbon chain accordingly. Okay, if you can see from here, we have 4 carbons, which is our longest chain consists of 4 carbons. What does it mean carbon chain? Which is carbon that connected to the other carbon. So that is actually carbon chain. Okay, so 4 carbon. Okay, the prefix for 4 is but. I believe you came across before in our previous lecture. Okay, how actually prefix is used to indicate the number. Okay, 1 is math, 2 is F, 3 is prop, 4 is put, and so on. So I hope you can actually refer to your previous notes. And because this compound you identify earlier belongs to alkane, so the suffix or the ending name must end with "ane", which is A and E, indicate for indicating that it's actually alkane. Okay. So the longest carbon chain name is butane, okay, which is the mixture of the name of prefix and suffix. So identify, step number 4, identify the substituent group and position. In this case, we don't have the substituent group. Okay, all actually only hydrogen attached to the carbon. So I'm going to show you later on what does it mean by the substituent group. Okay, so in this case we can actually simply ignore step number 4. Step number 5, name the alkene. So basically the name is butane because there is no other substituent group for us to actually include in the name. Okay, so it's quite simple. Okay, step number 1, remember, find or identify the longest carbon chain. So you need to remember it's not always the carbon chain is not always straight, so you can actually bend and slightly depend on the drawing. Okay, as long as each carbon is connected, so that is actually we can call it chain. Okay, step number 2, number the carbon in the carbon chain. So just practice the 2 way of numbering. From the left to the right and right to the left. Okay. Step number 3, name the longest carbon chain accordingly. So you can see how to name the carbon chain. It should consist of prefix indicating the number of carbon and suffix indicating the homologous series. Okay. Step number 4, identify the substituent group and the position. So if you do have the substituent group, you need to know which location this substituent is attached. In this case, where in this situation, the numbering is quite important. So you want to know where is actually this substituent group is attached to the compound or is attached to the molecule. And finally, you can name the alkene, right? So remember 5 steps. So give 5. Okay, so you remember that. All right. So this is actually the information about the substituent group. Okay, so substituent group at your level basically coming from two main group. The first group we call it the alkyl group. Okay, this part. Okay, this group is actually also known as alkyl group. Okay, basically the alkyl group is very similar to alkene. Okay, apart from it's missing one of the hydrogen. Okay, so if you see methyl, it consists of 1 carbon. Okay, ethyl consists of 2 carbon, and propyl consists of 3 carbons. Okay, this is what we call alkyl group. Or we can also have the substituent group. Okay, so basically substituent group can either be atom or group of atom. In this case, this one is atom, so it can comes from the halogen. Okay, it's come from halogen. Chlorine, bromine. This is just 3 example. It can also be iodine. And so on. And here as well, it can be 4 carbon. Which is called butyl. Okay, so just to actually expose you about the substituent group, which you're going to come across later on in the naming or in terms of drawing later, right? So if coming from, if the substituent group is halogen, so the name actually like this, okay, fluoro, okay, INE for the atom is replaced with O, okay. For example, chlorine, INE is removed and is replaced with O. Bromine become bromo, and fluorine become fluoro, and iodine become iodo, right? So this is actually the substituent group. Okay, so let's try this one. Okay, so this one is quite easy to name, right? So can you name this compound? So I'm going to give you a couple of minutes. Okay, you can actually pause the video. Okay, and then attempt. Okay, this question. Okay, you can pause the video now. All right, I hope you managed to actually name this compound. Okay, let me show you how to name. Okay, remember our first step, our step to name. Okay, we have 5. The first one, identify the longest chain. Okay, here is the longest chain. So the longest chain consists of 5 carbons. Okay. So number, okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So step number 2 in numbers. Step number 3, name the carbon chain. So 5 carbon. Okay, the prefix is pent, and this is actually alkane. The suffix is in, right? So step number 4. So we don't have any substituent group over here, so we can ignore step number 4. And the step number 5, name the alkene. So basically the name is pentane. Okay, the name is pentane. It's quite easy. Okay, the name is pentane. Okay, right. Let's try the second one. Okay, this one slightly different. This one you're going to see the importance of numbering the carbon chain. All right. Okay, as you can see, step number 1, identify the longest carbon chain. So we have 1, 2, 3, 4, 5. If you can see over here, we can have this as the longest carbon chain, or you can have this as your longest carbon. Oh, sorry. Okay, I need to actually erase some of that. Okay. Okay, you can have this as your longest carbon chain. Okay, so let's start from the red one. Okay, the red one, we know we have 1, 2, 3, and 4. And the purple, we have 1, 2, 3, and 4. So basically, either way, the maximum or the longest carbon chain that we have is 4. So to make it easier for you, I'm going to choose the purple one. Okay, I'm going to choose the purple. So it's going to be easier for you because it's straight chain. Okay, so this is our longest carbon chain. Okay, let's move to step number 2. Number the carbon chain. Okay, 1, 2, 3, 4. 1, 2, 3, 4. Okay. And then step number 3, we can actually name our carbon chain. Okay, prefix. So we have how many carbon? 4 carbon. So for carbon, the prefix "-but", and then suffix. This is alkene, so it ends with "-ane". So the name of our carbon chain is butane. Alright, now let's move to step number 4, which is identify the substituent group. In this case, do we have the substituent group? Can you identify the substituent group? Okay, so I believe now you see the substituent group over here. So basically this one is actually the substituent group attached to the the carbon chain or carbon backbone. Alright, if you can see, the substituent group consists of one carbon and 3 hydrogens, so it's called CH3 is called methyl. And the position, so we need to identify the position as well. Okay, the position is, if you can see over here, when you number the carbon chain, I told you earlier that you need to practice numbering from the left to the right and right to the left. And this carbon, basically, if you see, the number can either be number 2 or number 3. So which number that you're going to choose? Okay, which number you're going to choose? Always, in this case, we're going to choose the smallest number, which is number 2. We're not going to choose actually the way we number or the way we name the alkene. Basically, we're going to start with the smallest number first. Okay, in this case, the smallest number is 2. So basically, the position of methyl is 2. Okay, so we put the number over here and then we put the dash. Okay, this number indicate the position of methyl group. Okay, so number 5, basically we going to actually we are going to actually name. Okay, the name of the alkane consists of backbone and also the substituent group. Basically, the name become 2-methyl butane. Okay, it consists of this one coming from the backbone, and the first part coming from this part coming from the substituent group. And this number represent the location of substituent group. And this is basically the substituent group, and this one is actually carbon chain. Okay, so basically this is how we actually name alkene for more complex or more complicated compound. Okay, so it's quite what we call it it's quite systematic in a way that we name. So if you give this structure for all chemists in the world, they're going to give you the same name. Okay, because we follow the same principle, or we follow the same steps in naming the alkene. Right? So I hope that a few example, in terms of naming alkene, going to actually enlighten you how to actually name the alkene. Okay, name the alkene. So if more than one substituent group can be found in the compound, okay, if there are 2-methyl, okay, 2-methyl, so it becomes dimethyl in the name. Okay, so we're going to see, maybe you're going to come across later. So you can also see some of other example in the textbook as well, right? So other than knowing how to name, okay, sometimes you are given name and you are asked to draw the structure. So basically, these two skill is quite important, because sometimes when you read the name of the compound or the name of the member of homologous series, you're supposed to be able to draw that compound. So I have summarized over here. There are three actually basic steps for you to draw the alkene. Okay, the first step is actually you need to draw the longest carbon chain. As I described earlier in the naming, you know that the part that you can find the prefix is actually the carbon chain. So it's quite easy for you to identify later on in the name. And then draw the attachment group. Okay, draw the carbon chain first, and then you draw the attachment group. For example, you have methyl group, so you know that it consists of one carbon, three hydrogen. And then you need to identify as well the location of the attachment group, or sometimes the attachment group, basically what I meant here is the substituent group. Okay, some books call it attachment group, some books call it substituent group. And at the finally, make sure that when everything is drawn, okay, you already drew you already drawn the carbon chain, and then you draw the substituent group. The final part is actually complete the molecule by drawing the hydrogen, because as you are aware that alkane is actually hydrocarbon. And remember, this one you cannot forget. Remember, each carbon atom cannot have more than four. So carbon atom will always have four bonds, not less and not more. Okay, just four bonds. Right. All right. Let's try. Okay, drawing the alkene. So butane. Okay, you know that this is actually our prefix. Okay, I think I want to change it to black so it's easier for you to see. So butane is 4 carbon. 1, 2, 3, 4. Okay, you don't see any additional name other than butane. That means that this compound does not have any substituent group. So you can actually proceed to the last step, which is adding the hydrogen. Okay, so this is the last part. As you can see, one carbon. Remember, after you draw, you must actually check. Okay, each carbon must has 4 bonds. Okay, this carbon 1, 2, 3, 4. 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 So all 4. So if you are about to write the chemical formula for this one, so this one is C4 become H10. Right? This one is for butane. Okay. Would you like to try for the second one? How to draw 2,3-dimethyl pentane? Would you like to try? Okay, you can pause the video now. Okay, you can try to draw 2,3-dimethyl pentane. Okay, pause the video now. All right, I hope you managed to draw this compound. Okay, let's actually scrutinize a little bit. Okay, what do we have here? Okay, so the first one is, I told you earlier, this one is actually location. Location of what? Location of this substituent group, and this part is actually carbon chain. So what you need to do first, you need to draw carbon chain. So pentane, how many carbon? 5, correct? 1, 2, 3, 4, and 5. Okay. So because when you want to draw, okay, when you want to draw the molecule, the structural formula for alkene, so you can decide which carbon is actually carbon number 1. Okay, so in this case, if you decide this one is 1, 2, 3, 4, 5, so it's easier for you. So because you can see over here, we have 2 methyl group, which is at carbon number 2 and carbon number 3. So you just add 1, 2. Okay, so methyl is CH3. Okay, so now you can complete the rest of the structure by adding hydrogen. Because when you draw the structure, you don't have to actually do the numbering left to right, because you are the one who actually deciding. Okay, deciding the number. And if you see, from this drawing, you are definitely putting the number is correct, because if you put the number 1 starting from the right, you will see that your attachment group will be located at carbon number 3 and carbon number 4, which is not correct, because we're going to use this, we're going to actually assign the smallest number. So basically this is the structure for 2,3-dimethyl or dimethyl pentane, right? So it's not that difficult. Okay, I hope you can grab the concept, and then of course you need a lot of practice. Okay, can you try this one as well? 3-methylhexane. Okay, 3-methylhexane. You can pause the video and then you can try. Okay, pause the video now. All right, let's see, or let's scrutinize the name again. Okay, as I told you earlier, this one is location. Location for what? Location for the substituent group. And this one is actually the carbon chain. How many carbon hex? Correct. Hex is 6. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. Okay. We have one attached substituent group which is located at carbon number 3. 1, 2, 3. Here. CH3. Voila. So what you need to do now, just adding the hydrogen to complete, okay, the structure. Okay, as I told earlier, don't forget to check. Even sometimes I forget to actually draw the correct number of hydrogen. So make sure all carbon have 4 bonds, even this one. Okay, 1, 2, 3, 4. Okay, so this is basically the structure for 3-methylhexane. Okay, hopefully with the example I've showed you just now, you can actually get the idea how to actually draw an name. Okay, physical properties of alkane. Okay, so this is basically you can get from the books. So you don't actually need to memorize all these numbers. You just need to know about the trends. Okay, so basically some properties, for example, alkanes insoluble in water, do not conduct in electricity. And then if you can see, as the number of carbon per molecule increase. For example, for methane, we have 1 carbon atom per molecule. Ethane, we have 2 carbon atom per molecule. Propane, we have 3 carbon atom per molecule. So what happened? The molar mass increase, melting point and boiling point increase. Physical state at room condition changes. Okay, so what happened? Okay, if you can see that the first four members of this homologous series exist as gas at room condition, and then as the number of carbon increase, carbon atom per molecule increase, the melting point increases, and then of course the physical state also increase. Okay, here we have start from carbon number 5 onwards become liquid and so on, and then at one particular point, of course, you will find the member of this homologous series exists as solid, right? So this is what I meant earlier about the physical properties. So you don't have to know what is the boiling point of butane or boiling point of octane. You just need to know the trends. Okay, you just need to know the trends. Right, so the chemical properties of alkane, basically 2 important reaction. Okay, one is a combustion reaction. So I showed you just now the example of ethane under complete combustion. This is what we call complete combustion. You can also have incomplete combustion. You can find earlier. So remember, for the combustion process, okay, all hydrocarbons or most or all organic compound that undergo combustion, the product will be 2. Okay, the product will be carbon dioxide and water. Okay, the easiest way to actually balance the chemical equation using CHO. Okay, this you balance in sequence. Okay, balance the carbon first. For example, ethane, you have 2 carbon, so you put 2 over here. And then secondly, you balance number of hydrogen. Ethane have got 6 hydrogens, you put 3 over here. And the last one, you balance the number of oxygen. So from here you have 2 times 2, here is 4, 3 times, so this one is 3, so basically you have 2 oxygen, you have 7 oxygen on the right. Because oxygen on the left is O2, so you can actually use the fraction. Okay, you use the fraction to actually make it 7 oxygen, right? So this is how you do it, because it is allowed to use fraction when you balance the chemical equation. Okay, don't feel odd when you find when you see the fraction, okay, in the chemical equation. It is allowed. Okay, it is allowed. And then the second reaction involving alkene is called it's not the addition. Okay, I apologize for that. It's called substitution. Okay, this is wrong. It's called substitution reaction, where it's supposed the structure of the molecule is supposed to be like this. Okay, so what happened? Okay, one of the hydrogen being substituted by chlorine. And this is why it's called substitution reaction. And this reaction is actually, it can proceed stepwise. Initially, it replace one chlorine, substitute 1 hydrogen, and then it can go on. It can substitute 2 hydrogen, and at one point, okay, what you will get this one. Okay, this is called tetrachloromethane. Okay, where all hydrogen has been substituted by by chlorine. So the main important condition is you need a sunlight or the UV light for this reaction to proceed. Without this, the reaction will not proceed. Okay. So basically, this is actually a chemical properties of alkane. So basically, we already covered what you need to cover for alkane. So this is actually task number 1. Okay. As you can see from the instruction that you have for your assignment, so you have tasks. Okay, you have 3 tasks basically for this lesson. So basically, I actually put this task in between the lessons, so that it's easier for you to follow and it's easier for you to actually refer to when you want to find the answer. Okay, so you can actually pause the video if you want to complete the task, or you can actually rewatch the video later to complete the task. So basically, you need to actually write the answer for this task in a piece of paper. Okay, it's a piece of paper, so it's going to be easier. It's not going to be very difficult. Basically, we already covered this part in our previous slide, so you can actually watch the slide again if you want to get the answer. Right? Okay, this is actually task 1. So now we're going to proceed to the second part of our lesson today, which is alkene. Okay, if you like to take a break, you may do so, or you can actually proceed straight away to alkene, because for alkenes, I'm going to cover very much similar what I already covered in alkene. Okay, so basically you expect we're going to see very similar slides, but with different information on the slide, because we are covering second homologous series for the organic chemistry, which is alkenes. So don't confuse with alkane, because for alkane the name ends with A-N-E, while for alkenes the name ends with E-N-E. Right? Okay, a very similar slide what you see just now. Can you actually write down 4 information that related to alkene, similar to what we did for the alkane? Can you write it down? Okay, correct. So alkene is actually hydrocarbon, because alkene consists of carbon and hydrogen only. Okay, but general formula is different. Okay, if the alkane is CnH2n plus 2, the general formula for alkene is CnH2n. So be very careful, and also alkene, the end start from 2, not from 1. Okay, be careful. So this is not 2, 3, 3. It's supposed 2, 3, 4, and so on. Right? So alkene is considered unsaturated, because alkene consists of what? Consists of double bond. Okay, so alkene consists of double bond. We have another member which is also hydrocarbon, is known as alkyne. Okay, which we're going to cover in your when you are in Form 5 later on. Okay, so basically the hydrocarbon we have alkane, alkene, and alkyne. Okay. This is how to spell alkyne. Okay, alkyne is a hydrocarbon that consists of triple bond. Right. All right. Naming the again. This is what happened when you actually just duplicate. But I purposely do it so that you will notice that actually the name of for this homologous series actually end with alkenes. All right. Let's see how to name the alkene. Okay, step number 1 still the same. Okay, identify the longest carbon chain. So you will do exactly the same what you did for alkene. However, you need to remember, if the longest carbon chain that you want to actually identify must include carbon-carbon double bond. Okay, so you cannot ignore, because carbon-carbon double bond is the functional group for alkene. Right? In this case, we have 4. Okay, Number the carbon which double bond get the smallest number. I think previously I showed you that you must practice that numbering. When you number the carbon chain, you need to number either from the left to the right or right to the left, which is we do it. We do the similar practice here. So you left to the right and right to the left. Okay. But you need to identify that the double bond get the smallest number. So for over here, your double bond can get number 1 or number 4. Of course, number 1 is the smallest. If that is the case, we're going to use the purple numbering system. Okay, so this is how you do it. Okay, you going to assign the smallest number for the double bond. Name the longest carbon chain accordingly. Okay, this one is very similar what we did for alkane. Okay, here we have 4 carbons. So basically, the prefix is but and the suffix is in, ene. However, there's one more thing. There's actually slight difference from alkane. Here we also need to actually include the number of we need to include the position of the double bond. So it's going to be easier later on if you want to draw. Okay, so the position of double bond here, you can see that it attached to carbon number 1. Okay, so position double bond is carbon number 1. So the name of the longest chain become but 1 in, but dash 1 dash in. Okay, this is how it. So there's no space in between this. Okay, but dash 1 dash in. Okay, that is actually the name for the longest carbon chain. Identify the substituent group, same what we did for the alkane. So identify. Okay, we have here because we are using the and then the position, because we are using the purple color numbering system. So you cannot for example, initially, because the smallest number for double bond is number 1, you use purple, and then suddenly you want to assign the smallest number for substituent group. You cannot do that for alkene because we are using the purple numbering system. We're going to step for that numbering system. In this case, our substituent group is located in carbon number 3. The substituent group is methyl. Location is number 3. Okay, step 5, name. So basically the name consists of substituent group plus the longest chain. So the name is 3-methyl-but-1-in. Okay, so because if you follow this step systematically, it's going to be easier for you to actually name. Okay, the alkene, or even alkane, or even the other homologous series will have a very systematic way for you to name the compound. All right, let's try this one. Okay, so we have example of molecule over here. Okay, so step number 1, identify the longest. I believe this one is very similar to the first one, I think. Okay, so the longest, so for the prefix is but, because for carbon, the location of 1, 2, 3, 4. The location of the double bond is carbon 1. Okay, and then the suffix is in. The name is but 1 in. Okay, the name of your longest chain. Okay, and then identify your attachment substituent group is located at carbon number 2. Substituent group is methyl. Location is carbon number 2. So the name is 2-methyl-but-1-in. in. So you can see over here, okay, is different from the first one. Okay, the first one is 3-methyl and this one is 2-methyl. Just the difference in terms of the location of the substituent group. Okay, so this how, if you follow, then I believe it's going to be easier later on. You might not need to use the follow the step anymore if you actually really know how to do it, right? Okay, can you try this one? Okay, you can actually pause the video if you want to actually answer this question. Okay, pause the video now. I believe you might need about 2 or 3 minutes to actually name. Okay, pause the video now. All right, so I hope that you managed to actually name the molecule. I'm going to use different color over here so that it's easier for you to see. All right, step number 1, find the longest carbon chain. All right, so I'm going to show you a few over here. Okay, we have one. So the second one will got purple. So 1, 2, 3, 4, 5. Remember, our longest carbon chain must include carbon bond, carbon double bond. Okay, the second one, it can be like this. 1, 2, 3, 4, 5. Still 5. And we have another one. Okay. 1, 2, 3, 4, 5 still. Okay, so basically the longest carbon chain that we can get from this molecule just 5. So I'm going to use the highlighter, okay, to make it easy. So I'm going to use the straight chain. Either way is fine because you're going to get the same name. Okay, either way is fine. You can go to get the same name. All right, let's work out the name now. Okay, the longest carbon chain, okay, prefix equal to 1, 2, 3, number 5, 5 carbon. So 5, the prefix is spent. The location, okay, number your 1. I think I need to use different color to make it easier for you to see. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, if you can see, the smallest number for double bond is number 2. So location of double bond, number 2, suffix, which is in. So the name of your carbon chain is pent to in. All right, the next part or the next step is actually identify the substituent. I'm going to use highlighter again. Okay, we have 2 substituent group. Okay, this one, okay, is good that we can use different color. What color? You get blue. Okay, so we have 2 substituent group over here, but the substituent group is the same. Okay, both are actually methyl group. Okay, substituent group sama dengan or equal to methyl, location 2 and 3. So substituent group become dimethyl because we have 2 methyl. Okay, so the name basically we are combining the substituent group and also the carbon chain. Okay, the location first for this substituent group 2 and 3. What is the substituent group? It's actually dimethyl because there are 2 methyl. And what is your carbon chain? Is actually pentoene. So basically the name of this compound is 2,3-dimethyl pentoene. Okay, it's not that difficult, isn't it? Okay, so you need to practice more. All right, same like what we did for the alkene, so you also need to know how to actually draw your alkene. Again, alkene, okay, not alkene. Right, so I actually add one more steps, okay, compared to alkene. Alkene only got 3 steps, but this one got 4 steps, because this step you need to I need to include, which is you need to draw the double bond. Okay, I need to draw the double bond with at the respective position based on the name. Okay, and then draw the attachment group, and the rest is the same with alkene. The first one, hex 3-in. So hex, basically this one is actually prefix. This one is actually suffix. This one is actually location of double bond. So how many carbon? Hex is 6, 1, 2, 3, 4, 5, 6. What is the location of double bond? Number 3. 1, 2, 3. So double bond is number 3. And what we left is just actually add hydrogen. For alkene, you need to be very careful because we have double bond. Because this one, double bond is considered 2 bonds. So 1 bond, 2 bond, 3 bonds. So you need just one more bond over here. So be careful. Don't add additional bond to carbon. Remember. Okay. So basically, this is the structure for hex 3-in. Okay, hex 3-in. Okay. Just check if I did any mistake. Right. So this is actually drawing. So can you try this one? Okay, 3-ethyl pent-1-in. As I told you earlier, you can actually pause the video if you want to draw, so that you can take your time to actually draw. Okay, pause the video now, and then I'm going to actually continue with the drawing later. All right, so I hope you managed to draw the structure for this compound. So this one is what? This one is location of substituent group, and this part is actually the substituent group. And this part basically your carbon chain. So carbon chain consists of prefix and suffix, right? So pent-1-in. So remember, you always draw the carbon chain first. Pent-1-in, how many carbon? Correct. Okay, pent-1 is 5 carbon. 1, 2, 3, 4, and 5. So second step is actually you need to draw the double bond. What is the double bond? Carbon number 1, correct. Carbon number 1. And then, okay, just to make sure that you remember, 3, 4, 5, the number. All right, so we have what? We have the substituent group over here. The location is carbon number 3. Is actually ethyl. Okay, ethyl is basically 2 carbon. CH2, CH3. Okay, this is your substituent group. Now, what left? Just add the hydrogen. Careful over here. You just need 1, 2, 3, and 4. Okay, so basically this is a structure for 3-ethyl pent one in. Okay, so this is the structure. All right, so we come to task number 2. So this is actually the continuation of task number 1. So when you complete your folio later, so make sure that you actually name the task, so it's easier for your teachers to actually mark the task later on, right? So you can actually pause the video as I mentioned earlier, or you can actually complete later on for the task. Okay, this is task number 2. All right, I'm going to finish off this topic with the chemical properties similar to alkene. However, you can see over here, you only have roughly about the name of the reaction involved in alkene. Okay, because you will see the answer at the end of the slide later. Okay, so basically alkene, we have 5 important reaction: combustion reaction, hydration reaction, polymerization reaction, oxidation reaction, and also addition reaction. Okay, and addition reaction is the common general name. So under addition reaction, you can find that these alkene undergo the hydrogenation. Basically, we are adding hydrogen, and also halogenation. We are adding halogen to alkenes. Okay, so part of the task later on, you need to actually read through this reaction and write down the chemical reaction. So that's why I left blank for this part. So this is your task to actually find out about the chemical properties of alkenes, right? So this is basically task number 3 because I want to make it short. Okay, so task number 3 includes the chemical equation as well as the physical properties. So you need to do it on your own. You can use you can use the information provided in alkanes just to get you how to get the answer for this task. And the last one, I want you to compare and contrast between alkane and alkene so that you can see they are similar in a way, but they are also different in many ways. Okay, so basically this is the final task for your folio. Okay, so hopefully you need to actually watch the video till the end before you can actually complete the task. Hopefully you can also know where to get the answer from, but because that's the reason why I actually splitting the task into different location in the video, so that I hope that it's going to be helpful. I hope it's going to help you to actually find the answer. And don't worry, you can find the answer from your textbook, and also you can get some information from the website as well. So do read more, because of course just watching this video, it might not be sufficient for some of you to answer the question. Okay, you might need some extra information, so feel free to do so. But I do believe that the video alone is going to be helpful for you, because later on or after this, in our next session, I'm going to expose you, or I'm going to share with you some question, some exam, what we call it, exam oriented questions, so that you know what we normally ask in the exam. But if you have the skill, so you don't have to worry about how to answer the exam anymore, right? I think basically that's it what I want to cover for this session. I hope the session is beneficial for you, and just keep motivated, read more, and spend more time to actually revising for your what we call it, for the previous lesson, because basically they are connected very much in a way for you to actually build a very good understanding about the topic. Okay, so thank you very much for your time. Okay, I do apologize if during the lesson you find that the slide maybe there are mistake in the slide, or you find my voice not very clear, so I apologize for that. It might it might cause from my poor internet connection or so on. But I do hope that this effort not going to be wasted. I do hope that this effort going to be useful for you. Okay, thank you very much. I can see you again in our next lesson. Thank you.